Hello and good afternoon. So as you can see here, we've got the first set of switchblades in. This curved rail, the innermost rail. And that's going to have a tie bar on that side and a tie bar on that side. So then when a train wants to go from this route to this route, both these tie bars get pulled, which allows the train to move around that way. To support that, rather than like a normal point where you'd have a piece of rail with only one end chamfered down to a point, in this we have 2 points. So rather than having one single piece of rail and having to get it perfectly matched up, I've just cut this in half. So I've actually got 2 pieces of rail, and I'll be filling that join up with super glue or something so that it's not visible at the end of the day. This one's in situ already, so if I move this, I can move the point, and that's fine. I mean, it's gonna require a little bit of fettling there, but ultimately that's what needs to happen. In terms of how I achieved that, it was with jigs again. So the first jig that I chose to use was this one here, and if I get the piece of rail, I've trimmed this now to the right size, so it won't fit perfectly, but essentially you have a piece of rail that fits, it's long enough to fit underneath this clamp, and then you have a sanding block and stick, and you rub it backwards and forwards, and depending on where this brass saddle is, it raises and lowers the angle to get the right amount of chamfer on the blade. So if I turn it to the right area where it is here, you can hopefully you can see there's a few centimeters there of plain rail at the end, and so you can measure that, and you can measure that a C-type turnout switchblade should have whatever it is, 3.5 centimeters of plain area, and that's something you can do. But I found this was just reliable and easy, and it's only a few pounds, so I picked that up. Next, if I zoom in over here, what you'll be able to see is there's a little chair plate in there, which is what is fixing the switchblade to the tie bar. The reason that we don't use metal all the way, obviously, is because both rails need to be opposite polarities. So you have to use something like plastic in between, or have a dropper going through the layout, and then connect it underneath with something plastic or non-metallic. So for now I'm trying to use these. Again, that's only a few pounds, and they come as a little kit. So this is the remains of a kit. So there's a little bit of wire in here, and some of these little chairs. Here's one I've used earlier. And with this one, use this jig, which is now getting pretty filthy. But essentially, there's a little hole here that you cut that out and drop that in. Then you slide the rail in across and solder it in place. And then that aligns this lip exactly on the tip of the switchblade, which means when you look down here, it's aligned nicely and vertically, and it's all going good. So my goal for this evening is to get this other rail in. Get this other rail in here with the chair plate and the little piece of wire that will go down and connect into this tie bar, and mount it on this side. And then what I'll then have is a kind of curve that will run all the way through, and then I can lay the other rail. See, and here all we've got is this diamond, but actually when this curve is in place, the corresponding curve needs to exist here. And it seems to be a rule of thumb, you're always working on stuff that's on the inside first and gauging the outside to it, rather than the other way around. So I'm going to do that, and yeah, then there'll be the next update.